Okay, Bismillahirrahmanirrahim. I think we start our lecture today for chapter 2. Chapter 2 is namely Vienna development method. Okay, what is a Vienna development method? Is an approach of model-based method that structure the based on the mathematical oriented. This one, the main objective is to specification system development. It also applied for software and also for hardware. Okay, and then in general, formal. If you look back last week, formal specification is languages that fall into two classes: algebraic languages and model-oriented languages. Okay, but for this one is model oriented. This one is model oriented based method lah. Okay, VDM in VDM in general is a mathematical oriented method for specification system and development of the software lah. Basically, for the development, we use the SDLC like waterfall model, like agile. Okay, in general, VDM is a model-based method. Model are specified as object and operation on object, whereby the object represent the input, output, and internal state of the system. Okay, basically for the model, the model piece. Okay, basically for this one, we specify as object and operation, as object and operation on objects. Okay, this one basically we do on objects. Whereby the object represent the input, okay, whereby the object represent in as an input, okay, output, and internal state of the system. Okay. Boleh baca ke tulisan saya? Can you boleh? Okay, normally the VDM encourages the layered top-down development approach based on use abstraction at the uppermost level of the system description. Okay, basically this one for the VDM, uh, we look at the highest level, highest level. And then basically for the specification is typically given as rather the abstract model, okay, that represent the object. Okay. For model, we use normally the abstract model. Abstract model. Okay. The abstract model normally explaining the specification. Okay, what is VDM? VDM is a collection of techniques. This one is more specific, definition for modeling, specification, and design. Basically, when you talk about the VDM, we use the computer-based system based on the mathematical rigorous approach, basically for formal specification. This one a little bit about the history in the late 1970s. IBM uh, has introduced a group of techniques and tools based on the formal specification language that called or named as a VDM specification language, and it has an extended form VDM plus plus. Okay, for the VDM plus plus, it's basically for the object-oriented approach. For VDM SL specification languages, we use the structured approach. Okay, there is a history of industry that using VDM. Basically, for the industrial approach, they are using a complex system, and it tools. Tools basically we use the overture tools or interpreter, or sometimes we use the API core bar or document generator, and a growing body of research and informalism has led to notable contribution. Contribution here means that we interpret the abstraction using the uh, hardware and software specification, and then contribution to engineering of critical system, compilers, concurrent system, and in logic for computer sciences. And then for the VDM itself, more likely, this one is more on the testing and proving the properties. Yeah, so far the question. Do you have any question? Is it okay? Ami okay ke Ami? Okay, Zuleha okay ke Zuleha? Ada soalan ke? Don't forget after this you need to do some reflection to upload to Padlet. You need to upload to Padlet. Okay, VDM also has a number of convention, which means that it have a syntax that are not detected by the VDM that have been used to increase the readability of the model. Okay, basically there are several naming convention uh, to declare based on the syntax and semantic using the ISO standard. ISO standard basically they are using SKI. Okay, SKI. Okay, there are name in our model begin with a capital letter. This one is a very general syntax. It must begin with a capital letter. And then secondly, function names always begin with a capital letter, and then formal parameters and object are always in the lower cases letters, and then all function to INS, initial navigational system, ending with at INS. Similarly, names of EC is external computer, specific function and in at EC. Okay, for the VDM SL and VDM plus plus, they have several syntax and semantic. Okay, for the VDM SL and VDM plus plus, syntax and semantic are described at the length in the VDM tools, languages manual, and in the available text. Basically, this one we use the overture a virtual function. Okay, not a virtual. Cool. Okay, and then there also contain a formal definition. This one I have explained that using the SK syntax. Some texts prefer a more concise mathematical syntax. Okay, in VDM SL, there is conventional modular extension, whereby the VDM++ has traditional object-oriented structuring mechanism with classes and inheritance. Okay, please be reminded we have VDM SL and VDM++. Okay, for VDM SL is more on the conventional modular. Modular, and for VDM plus plus is more on object oriented. Okay, and then for the VDM, VDM this tool is freely available but not being further maintained. For example, if you see LaTeX and LaTeX 2, uh, available to support the presentation of VDM model in ISO standard languages mathematical syntax. They have been developed and maintained by the National Physical Laboratory in UK. When you ask, is it VDM still being used? Okay, it is being developed and maintained by the National Physical Laboratory in United Kingdom. Okay, and then VDM SL, a model is system description given in terms of functionality. It is performed on the data, and then it consists of a series of definition of data types and function or operational performed upon them. This one basically based on the functionalities of the data. Okay, and then as you can see, we have several VDM components that entailing the environment for the modeling and development of sequential software system. Okay, first one we have a semantic domain. Semantic domain. It is a type that define the object to be operated on. And secondly is invariant. Invariant is a function that will limit the set of objects defined by the semantic domain by defining a set of conditions. Okay, for example, we have a Boolean statement. Later we see this one. And then number three is syntactic domains, types of that define languages in which to express the command for manipulating the object defined by the semantic domains. And then number four, we have formness condition. Formness condition that function that define when the command have well-defined effect. We have effect. And then the last one is semantic function. Function that define the effect of command on the objects defined by semantic domain. Here we have a VDM component. We have five of them. Okay, and then later we can see a state machine that using VDM model. But we would like to represent the protocol at a level is closer to original informal documentation without identifying the states and communicating component, but only specify the communication itself. Okay, later we see this one. Okay, for the VDM SL, please remember it is more on the conventional approach, conventional modular approach that have some functionality that perform on data For example, we have a Boolean here, Boolean, okay. We have natural numbers including zeros, and 81 natural numbers excluding zeros. We have integers, we have rational numbers, we have real numbers, okay, we have characters, and then we have a structural token, and then we have a code type. Code type. Okay, for the condition that expressed by Boolean function uh, to be obeyed in any event sequence of arbitrarily length. For example, we have two groups here, false and true. Okay, then data type. Data type are defined to represented the mean data. Basically, we want to manipulate the data of the model system. And then we define each type of definition by introducing new names and give some representation. This one based on the data. And then, for example, we have a modeling user identifier for login management system. Okay, we define types user ID as a natural number. This one we not fix. We not fix the minimum and maximum number. Okay, because of what? Because we have this model is appealing because of the behavior. The behavior is decided by how each model defined by each other. Okay, later we see this one. The concept of modeling is a process of being willing to wait only a certain amount of time. Okay, okay, then for invariant, invariant is more on the complex expression that have a membership in a VDM SL. This one is to satisfy the invariant. We use definite set for the example. We have character equivalent to characters. Okay. Why we choose the membership? Because we want to add some complexity based on the model that we choose. Okay. Okay. So far, do you have any question? Ada soalan je? Okay. No, is it you faham ke tak faham? Boleh ke setakat ni? Apa dia? Data jenis apa? Data jenis ni basic data type ni. Apa dia? NAT dia. NAT tu natural number. Token. Structural token ni. Structural token ni nanti kita akan tengok. Dia normally bila kamu cakap structural token ni dalam Overture punya tools in Overture punya tools kita ada structural token. Sekejap. Kita type product sequences. Okay. structural token. Okay, basically kalau kamu tengok structural token ni, dia token like data items. Basically, this one is we determine for the sizes. For example, we have a token. Okay, we have token here. Less than or equal to 100 bytes. Okay, maksudnya kat sini token yang kita define ni, when we define the structural token, dia tak ada syntax tertentu lah. Dia it's not defined by the syntax, but it defined by the sizes, by the size of the quest or data lah. Okay, kalau kamu tengok kat sini token ni basically 100 bytes lah or 100 megabytes. Dia tak ada macam code type lah, maksudnya dia tak ada syntax. Boleh Amizan? Dia dia punya structural token tu normally kita define as a equal sign, less than or greater than. Okay, dia define yang ni lah, kita tengok untuk dia punya comparison. Okay, token, structural token, basically kita tengok comparison ni. Okay, ada soalan lain? Okay, kalau dalam in a programming, when you talk about token, you can see about the keyword, identifier, literal operator, and separator is namely as a token. But in VDM, if you talk about structural token, which means that you want to compare, okay, compare. It's more like the comparison. Okay, basic data types. Here we have numeric, character, tokens, and code types. For manipulating the values belonging to the data, we have provided some of the operation. As you can see, we have addition, subtraction, and etc. For example, we have Boolean operators. Boolean operators. Okay, and then operators such as equality and inequality, same goes to the structural token. We compare, and then the language that does not fix the maximum or minimum numbers that represented precision for real numbers. Okay, such constraints are defined whereby they are required in each model by means of the data type invariant. Okay, and then this one is Boolean operators. Okay, VDM also can model changes to global state. Okay, for example, here we have identifier must be no greater than 9,999. Would be expressed as follows. We use the comparison invariant and variant. For example, here invariant user ID is equivalent to user ID less than or equal to this one invariant. Okay, and then some invariant can be arbitrarily complex by logical expression, and membership of defined data type is limited only for those that satisfy the invariant. The other basic type, including the characters, we have characters. Okay, okay, in VDM, okay, I put another slide. Okay, VDM model, we have a data type, okay, and then we have a data type invariant, and then we have function and operation, and then we have precondition, and then we have a post condition. Okay. Okay, data type is how you want to reflect the problem solution, structure information. Okay, and then for invariant, this one express the properties, express the properties that should not change, okay, change the along any valid, okay, any valid history of model. And then we have a functional operation is which data is accessed and manipulated. Okay. And then we have a precondition, okay, which record the restriction assumed to hold the input, pre, and then we have post. Okay, precondition is we must do before the condition, and then post condition to specify how operation function should transform the argument. This one gives the result. How basically this one give a result. Okay, boleh Ada soalan ke setakat ni? Okay, do you have any question? Kaisha, okay ke? Kaisha? Okay, then we have a basic data type continue where specific name are required. This one we use the code, code type, and then for example we have modeling a traffic signal controller. In the traffic signal we have red, amber, flashing amber, and green. Amber, what color is amber? Amber is between orange and red. Okay, it is a color in between. In between, it's not orange. It is uh, more to orange. But it is the range between in between red and orange. Okay, and then okay for structuring in VDM. For structuring VDM. Okay, for structuring VDM, we use the ISO standard for structuring principle. They have a uh, three way. Okay, first one is module naming. Each module is syntactically started with the keyword followed by the name of the module. At the end, the module keyword and is written followed again by the name of the module. This one is a very modular approach. And then secondly, for the importing function that import some of the module, and sometimes we are importing several module in the different module, and then each module import started with the keyword from followed by the name of the module and the module signature. Okay, the import signature specific for type, values, function, and operations. Okay, for example, here we have a struct A. Okay, we need to access. We supposed to write the struct A and then pointed to the particular type of the functions. Okay, and then exporting. Same goes to import. We need to validate uh, which module signature that we exporting, because in the VDM SL we have some logic to specify the operation behavior, and then we have a functional and procedural approach. Okay, and then okay, this one is some example. We have types, and then we have some types. We have values, we have constant name, okay, state, system name, and n. Whereby the VDM SL, VDM plus plus is more likely to be object-oriented approach that have three key concepts. First one is the class. Secondly is inheritance, and lastly is access modifiers. For the class, each class is referred by the keyword class, followed again by the name of the class. And for the inheritance, is inherit construct from another class, and then followed by the keyword by its subclass. And then for the access modifier, we have a modifier keyword like private, public, and protected. Okay, for the functional modeling, okay, we have checked through the data which is accessed and manipulated. Okay, this one is computed properties. And then the The main mechanism for functional modeling uh, can predict over the input and the result of the variable. Okay, and term post condition give a result to the properties. Okay, and then for example, we have header square root x is a natural number, r is a real number. Okay, and then this one post r multiplied by r is equivalent to x. Here, post condition here does not define a method for calculating the result r multiplied by r, but give the state what property can be assumed to hold of it, which means that it not calculated the values, but only calculated the properties, the properties. Okay, and then specification would be satisfied by the example. Uh, Okay, and then note that the function of Vdm SL are required to deterministic conversion between Celsius and Kelvin, for example, and so that the function satisfy the example specification must be always return the same result for the same input. Okay, for example, if we have 32 degree of Celsius, okay, if you convert to Kelvin, okay, 32 Celsius convert to Kelvin is 305 Kelvin. Okay, same goes to when you go by 305 Kelvin is equivalent to 32 Celsius. Okay, in VDM SL function do not have side effects. Side effects which mean do not have the uh, global state uh, changes. Okay, for example, if you have a state consisting of a single variable, some state register using the natural number we could define as natural numbers. Okay, okay, this one in VDM plus plus is little bit different because we use the some state register equal to natural number, but we instantiate the object. We do some the instantiation in object. Okay, do you have any question? Ada soalan ke? Ada. Kalau ada as a summarization, VDM++ is a large language with many constructs that appear exotic compared to normal general purpose programming languages such as Java and C. We must remember the main objective of VDM is not to program but to specify a model basic. Okay, and then the level of abstraction is necessarily higher than a general purpose language. We can specify the general purpose language by using the set, map, and implicit functions without having to worry about how they will be implemented. Here we have a model SDFC for the structuring process. Okay, this one is the example of the incubator monitoring system. We have VDM SL to record increment, record decrement, read the value of the temperature. Okay, and then this one is to specifying the function by using the VDM++. Later we see in the Z notation. Okay, for the VDM SL, we must have the operational header, external clauses, precondition and postcondition. Okay, this one is the structure for VDM Exam. Okay, do you have any questions so far? Is it okay? Boleh ke? Hamizan boleh ke? Okay, kalau